Hi everyone, my name is Gianmarco Marcello and this is a presentation about using NIM for embedded software development. And I'll talk about my adventures in telecompute development in general with this language. So before starting, brief about me. I'm Gianmarco from Italy. I'm an embedded software engineer by trade and I love open source in general. I work in open source too. And I am the resident AVR enthusiast in the community. Alongside with that, I sometimes write on antima.it, which is sort of a technical blog that I have together with another friend of mine. And we mainly write about software engineering and hardware engineering. So in relation with the NIM community, I mainly develop and maintain two projects for the embedded 8-bit world. The main one is AVR.io, which is a collection of bindings and utilities that can be used to program and let's say develop software for 8-bit microcontrollers, 80 mega microcontrollers from AVR. And AVR Man, which is a sort of project configuration, project manager that allows you to create software projects both for NIM and C, and it supports CMake, it supports Nimble, and essentially it kind of takes care of the boilerplate generation for the project. I also sometimes, since this is not, I wouldn't say that AVR or 8-bit system are mainstream, I sometimes do minor enablement for this kind of system in the compiler whenever I found essentially any bugs or anything that is not working. And currently I'm experimenting a little bit with Nimony, which is the upcoming NIM 3 version of the compiler. I'll talk a little bit about this at the end and about what I think will be cool in the context of embedded software development. And if you want to contact me, you can use this email, and this is my GitHub. Okay, so let's get on with the context of this talk. So last year, or actually last NimConf, I talked about AVR.io in depth, which is this project that I'm writing and maintaining to offer compatibility and tools in general for programming AVR 80 mega chips. And this is not to talk about AVR.io, but I will use AVR.io as an example, and I will talk a little bit about it in the course of this presentation. But the main topic is this one, is using NIM to develop software for microcontrollers, okay? And specifically 8-bit microcontrollers, but a lot of these kind of topics I'm going to touch on can extend to other kinds of microcontrollers and really other kinds of embedded systems. And I'll share a couple of experiences that I had with writing both libraries and application in this embedded space, and the challenges of both of those and the tools that we can use in NIM to make our lives easier. And also a little bit of tips and configuration that can be used to jumpstart your projects in for an embedded platform. Lastly, I'm going to quickly talk about the future of embedded software, NIM in general. So the first question that probably popped in everyone's mind when talking about using NIM for this kind of stuff is why use NIM for embedded. So first of all, I'll start with saying that a lot of embedded software is still developed in C and C++. I would say that embedded software goes, lives in a separate, not separate reality, but at least goes with a different speed than mainstream software or general purpose software, maybe it's better to say. And NIM, offers better tooling for the experience for sure. Just the fact that you have something like Nimble or Atlas is incredible. And I think this is also getting much better in the near future with Nimony and NIM 3. Because, I will talk about it later, but I think the tooling story is getting better with some of the stuff that Nimony is going to offer. Also, NIM has this curious thing where I would describe NIM as a higher level language, but at the same time you have access to all the dangerous and fun bits that are actually needed for embedded software development sometimes when you really want to go low level and interact with the hardware. So it has this kind of really cool dichotomy where you can write software without having to care, for example, about memory management. And it's readable and it's accessible because of its syntax. At the same time, you can do micro optimization and you have a plethora of tools that you can use to really achieve whatever you want to do at a lower level. It also can be used for real-time stuff. I experimented a little bit with soft real-time application during the course of the last year, and it for sure can be done. And probably the coolest and the most, I would say probably this is the most important thing in NIM, is that it compiles to C. And this enables so many good things about NIM, but probably the main one is that, for embedded at least, is that it makes it so that NIM can be essentially used on any platform, because almost any microcontroller embedded platform, even the least mainstream, has a C compiler for it. So let's go onto using NIM on tiny computers, and that's this example that is on the screen right now is actually the first program that I attempted to write for an ATmega32.8p, which is the microcontroller that mounts on the Arduino Uno, probably the most famous board with a microcontroller on it ever. And the cool thing is that this program will run on an x64 server, on an MCU, on an ARM machine, and the only thing that you will have to change is a little bit of configuration. And how does this work? So first of all, think of the fact that since NIM compiles to C, you can actually make your NIM program run everywhere, right? How do you do that? So you have this kind of compiler API, let's say, through configuration files, where you can specify the backend that gets called for the C compiler on your NIM instantiations. And the way you do that is that you use this particular syntax. And let me go through it just so I can explain the whole thing. So first of all, you have to specify a CPU. So CPU, think of it like informing the NIM compiler about mainly the widths of the types that you're going to use, like your integers, your floats, your doubles, stuff like that. And the OS is it's self-explanatory, but in this case, you can also use standalone other than Windows or Linux and stuff like that, which essentially tells you there may be no OS, okay? When you're actually going to specify these kind of flags, then you can actually use them to build a triplet of configuration, where you can specify the compiler or linker that you're actually going to use for the C compilation bit. And also, as you can see, you can easily pass compiler linker flags through the passC and passL switches here. This is the NIM script configuration. You can use the config.nims file to keep this into your project. So how do you know how to actually specify this? Well, the compiler gets identified by this triplet here, cpu.os.compiler name. So if we go back one slide, you will see that in this case, you're using AVR as the CPU, standalone as the OS. So you will have to write something like avr.standalone.gcc. And then you use exe for the compiler and linker exe for the linker. And in this way, you just inform the NIM compiler about your platform, essentially, because the type information about the widths and whatnot, pointer lengths, will be automatically included in the CPU flag, and everything else gets included by these ones. Now, there may be a platform where maybe the NIM compiler does not have information about the specific platform, but generally, in my experience, it's really easy to either find one that exists and has the same structure of your platform, or you can just patch the NIM compiler. It's really easy, and generally, everyone is really happy to accept PRs. Okay, let's go towards another thing that I think it's really cool in NIM for tiny computers. So we're talking about the fact that it's really compelling to see it's really important in NIM, right? And one of the things that these enable is actually foreign function interface, the ease of use of foreign function interface. So this example here shows how to actually do this manually. So you use this import C header with this kind of decorator syntax, which is called a pragma. And you define a procedure with just the header, let's say, without a body. And by specifying where it's found, in which header file it's found, and the name of the function that you're trying to import from C, NIM understands where to get it, and it will just work. And this is the manual way of doing it. There are tools that lets you automatically generate bindings or automatically import stuff, and mainly, we're talking about CNIM and Futark. I don't know about anyone else, but I just use those two generally. Another important thing about using NIM on this kind of platform is the fact that NIM, I was talking about this earlier, allows you to use low-level constructs. Now, this is crucial for, especially when you're writing really low-level bindings, maybe to registers or peripherals, stuff like that. You will need to use something like pointers, for example, and also assembly blocks. Maybe it could be something that really is needed in order to interact with the hardware at the lowest level. So NIM generally allows you to use whatever you want. Obviously, these are dangerous constructs, and safety is not ensured when you're using this kind of stuff. So this is the other side of NIM that I was talking about earlier, that allows you to really tap into the low-level stuff and dangerous stuff. And another thing that is really cool in NIM is metaprogramming, probably alongside with the fact that it compares to C. For me, is the other big thing about NIM. And metaprogramming gives you a lot of tools. One of those is compile time functions, which are really interesting because they allow you to move computation to compile time, which is something that a lot of time you really desire when you're working on these platforms. Maybe you want to do verification whenever you're compiling something, so static kind of verification of, for example, settings that you're reading from somewhere when compiling, or you're embedding some data from other files into your code. And generics also really useful for both high and low level stuff, because they allow you to do stuff like, for example, not repeating code, right? Which is something that tends to be difficult when playing C, for example. Then templates. Templates are really interesting because, especially for embedded, because a lot of time when you're programming in C, for example, you really want to use macros, right? Sometimes to have true inlining, but macros in C are full of footguns, right? And templates are essentially macros, C macros done right with hygienic, they are hygienic macros essentially, also with the type system, embedded into them. So you actually can do normal programming within this kind of tool. So they're really interesting. This is a snippet that I took from a VRIO that lets me generate a C signature for wrapping procedures in NIM and making them work as interrupt service routines. And I use this within a macro, which I'll show you here. And macros in NIM are like the most powerful thing that NIM2 at least offers. And they are a way to taking in NIM abstract syntax trees and spinning out modified version of them. This macro here is a macro that will take a proc and wrap it with that signature here in the C-generated code and make it so that it can be used as an interrupt service routine. And the cool thing about this kind of stuff is it's really, difficult to get it right and you have to work it out a little bit. But once you've done that, you can really use it in an elegant way, which is the Nim way, with a decorator of sort like this. So it becomes something that it's really elegant, it's really direct and really readable. So this is something that you desire to do a lot, especially with libraries in embedded. You want to move everything that you can at compile time, so your runtimes will run really quickly without anything else other than what they have to do. And at the same time, you don't want to lose readability. You don't want to lose the ease of writing your code. And I think the Nim in this case gives you the best of both worlds. And about writing libraries, I told you that I maintain AVR.io, which is this library that enables AVR development in Nim. And I use many of those tricks there. You can take a look here for inspiration about how to apply some of these techniques. And another thing that I wanted to say is a sort of small announcement is that as of version 0.7, which I just released in February, AVR.io actually supports every 80 mega and 80 tiny MCU, except for AVRX Mega and AVR1 families of chips. So yeah, a lot of stuff that I'm going to talk about I learned from this experience here. Now let's move to another topic, let's say, in the always in this context of embedded software for Nim, using Nim in embedded software, which is some tips for application code. So last year, let's say, roughly the last 12 months, I've been developing an application in Nim using AVR.io, using also, let's say, general purpose platforms to interact with my boards in Nim. And I want to share some experiences that I had using Nim for these kind of applications. So first of all, I want to talk a little bit about ARC memory management, really briefly. I'm not an expert on this, but these are just a couple of thoughts that I had for these small, tiny platforms. So first thing, which is kind of cool, is that it is deterministic. So you can do soft real time, for example. And also, I want to say that if you're using something like no memory management, like I sometimes do, switching to ARC, it's almost no cost if you're not using anything additional. This is cool because if you're using something like custom panic handlers, which I'm going to show you in a bit, they will cost really not a lot in size. Okay, obviously, if you take a lot of standard library in, you will see slight differences. I haven't measured them in a scientific way, but I haven't seen them being really bad with reference to no memory management. But anyways, when you really need a little bit more space, you can use this incantation. You really have to know what you're doing though, because you're disabling the memory management, you're disabling safety checks, and you're changing the way that exceptions work. So really be careful when you're doing this kind of stuff. Another interesting bit of the language that I've been using quite a lot more in these, let's say, application days adventures is object variants. So object variants are a cool part of the language that essentially they are safer tagged unions from C. So if anyone ever used tagged union in C, they're just that, but with a couple of caveats that make them a little bit easier and safer to use. They're really space efficient. And one of the caveats is that you have to recreate the object where you're switching tags. Okay, so you cannot just switch tags because that's unsafe. And they will raise an exception or they will throw a panic when accessing an inactive field. Okay, so that's your safety mechanism with object variants. And they're really cool to use where, for example, you're implementing a custom protocol, for example, and you may want to put that the things that you receive through this protocol into one of the object variants, and it's really efficient in size. So essentially all the goodies from tagged unions, but with a little bit more safety. And the way you do that, you define an enum, and then you use that enum to define some cases for your object variants. A couple of gotchas here is that first, you can define fields that will be shared by all the cases, but if you want to have fields in a specific case, you cannot have a field in a case and a field in another case with the same name. Okay, they have to be different. Now, you can write custom panic handles that will catch these access errors, okay? Especially if you're using OS standalone. And you will need, though, these flags here. Okay, so we'll need arc and use malloc, in my experience at least, because the string initialization that will get sent to the panic handles needs malloc, or needs an allocator essentially. That's the way you do this with OS standalone. So in this particular case, I'm defining this in a this has to be defined in a panic override.nim file, and you will see that I'm just blinking an LED just so I know I have the visual check that something went wrong, and I am also printing anything to this particular user, so I will get the full crash in via user. So that's really nice to have for a small platform, because it allows you to have information about what's actually happening when something is going wrong. And also you want really these crashes, because they act as your kind of way of knowing that something went wrong in development, and you can fix it immediately, right? So that's really nice to use and very ergonomic in my experience. Now, for added safety with object variants, you can also verify these properties at compile time. I will say that the compiler is quite picky about this, so you may have to modify your code a little bit to make the compiler happy, but once you do that, you will not have. It's really great, because maybe the code gets a little bit more verbose, but it's for sure safer. Now, another hot topic in embedded development is node allocations. Now, this obviously is slightly different depending on your platform or what you have to do. Maybe sometimes it's good to allocate, it's not always bad. But let's say you want to keep stuff to the minimum, okay? So one thing that is really useful is to just use var parameters in general, and or the byref pragma that essentially makes this the default when passing a type, an object of a specific type in a procedure. And another thing that is quite interesting is non-owning views. So essentially using to open array. Now, this in my application, let's say adventures, this was a bit of a strange gotcha moment, because I thought slicing was free essentially in NIM, but slicing arrays actually allocates from what I saw, and you have to use to open array to have non-owning views essentially when you want to slice. Now, one bit about this that I want to talk about is the fact that OpenArray is not like a first-class citizen in NIM. I think you cannot use it in signatures of procedures and stuff like that. So sometimes you may need like let's say a non-owning view into your data structure. And what I generally do is write my own one, and this is completely unsafe. And especially, the pointer to uncheck the array is your first sign that this is unsafe. But you can do tricks like that to essentially use this to do this kind of thing without having to maybe do allocation and stuff like that, when you actually need to use views as parameters, for example. yeah, so that's a really cool technique. Another thing that I really love, we were talking about moving everything to compile time, is the fact that you can do compile time tables. This is one of the probably my favorite thing to do in NIM. A lot of times in C, when I have to do this kind of stuff, I have to write a Python script, a separate Python script. Now here you can just do everything with the same language. You can just wrap a procedure and call it a compile time into a const block, and it's just done by the compile. And then macro-based metaprogramming. So this is a very powerful but hard to get it right kind of thing. And it's my experience is best used in library code, so not exposed maybe in application. And I always prefer templates and generics when possible, rather than using macros, just because it's a little bit difficult also to reason about them for me specifically. This is a subjective kind of point that I have. Okay, so let's briefly talk about what the future hold for embedded, for NIM, and for both together. So right now I'm experimenting a lot with Atlas, and this is not maybe completely tied to embedded per se, but I think that Atlas is a really nice tool for managing your development environment, vendoring stuff and things like that, which I think it's important in these kind of projects. So I think that there's a lot of lessons to be learned with this kind of approach, which is the Atlas approach against the nimble one. I especially like the fact that it can also act as a sort of virtual environment creator, like we're used to in Python, for example. And another thing that I wanted to touch on is Nimony. So Nimony is this new experiment that the core devs in the NIM community are working on. And I did a little bit of experiments with that. And I have to say it seems really promising, especially on the LSP side of things. I have a couple of experiments with stateless LSPs, which is an idea I got from Discord and the forum from the core devs. And I will say that this is really cool, and it seems like it will be the future. It's really useful because it lets you, have modern toolings that really work for an incredible language like NIM, which sometimes had issues with tooling. And I'm really positive and optimistic about the future because I'm seeing really a lot of interest in this kind of direction. And I think that this is something that will unlock a lot of potential also for this kind of stuff that I'm talking about and working on. So I'm really happy and motivated about using NIM because I want to see where this is going to develop in the near future. And that's all from me. Thanks and grazie per l'attenzione.